Our last video for section 4.2. Let's look at the most complicated problems. And again, I said it in a previous video, but I'm going to say it again, and it's true for these ones that I did here. There's often not just one way to do these. I mean, there's usually a lot of ways, and that's particularly true of these last couple, especially G. When you have big parentheses like that, there's a couple good ways to attack it. I'm just going to show you one way, but there are other completely valid ways of doing this. All right, poof, like magic. I just typed it up so we could get a better look at it. Let me double check it. 49b to the fifth. Yep. That's it. Okay. So again, I can think of so many good ways to do it, and there are good reasons to choose each method. I'm just going to pick one. So, but the one thing I will say is that I think for the most part with these problems, it pays to simplify the inside first. It just makes your life easier as a general rule. Not always, but let's do that way. Okay, so if we're going to simplify, let's see. Does anything go into 49 and 64? No. Okay, so you're right, 49 over 64. Nothing's going to break that down. Cool. Then you want to do b to the, now remember, when you have b to the something over b to the something else, you can use that subtraction property. So it's 5 minus a negative 3. c to the negative 8 minus a negative 2. I'm using that subtraction property. And then it's all still to the negative 1/2 outside. All right. So then that makes it, you know what, I'm going to put it right over here. That makes it 49 over 64 b to the 8, right? Because 5 minus a minus 3 is 5 plus 3. c to the, now negative 8 plus 2 is negative 6. And this is all raised to the negative, there we go, 1/2 power. All right, that's okay. We can handle this. We've now simplified what's inside, right? Now, if you want, you should probably also put the b to the 8th up on the top, and you can put the c to the 6th down in the denominator and make it positive if you want. You don't have to do that. Like I said, there's so many ways to do this. But I mean, we never really like the negative exponents, so I figure, hey, getting rid of it, put in the denominator, that'll help. That'll kind of keep me straight. So now I only have one negative exponent left to deal with. Unfortunately, it's a doozy. Because he's outside the parentheses, everything gets raised to that negative power. So I have to do, let's see, I'm going to put this here. I have to raise 49 to that negative 1/2 power. In fact, I'm just going to copy and paste this. Oopsie. Oh, fine. All right, I'll type it up. 1/2. There we go. All right, then I'm going to have to do it again. b to the 8th is going to get raised to the negative 1/2 power. Right? And then 64 is going to have to raise to that negative 1/2 power. And then, see, c to the 6th is going to have to get raised. Oopsie. Whoa, sorry about that. I blew it up for a second there. All right, c to the 6th is going to have to get raised to that negative 1/2 power. All right. Well, remember, I made the note of it before, but I'll say it again. The variables use those properties, which actually makes them kind of easier in this particular problem. So all I have to do is multiply, right? So I'm going to take 8 times negative 1/2. So, and then while I'm on the subject, anything with a negative power like that, well, you know what? I'm just going to write it again. Hold on. Here, we're going to simplify down just a little bit. This is going to be 8 times a negative 1/2. You're going to multiply. So, oops, negative 1/2. You're multiplying those suckers. Sorry. There we go. Multiply 8 times negative 1/2. And then you're going to do the same thing down here. You're going to go c to the 6 times negative 1/2. Okay, now what is 6 times and 8 times negative 1/2? That's equal to, same thing as before, but it's going to be b to the -4 and c to the -3, like that. Now everything with a negative power has to get shuffled, right? So if it has a negative power and it's on the top, it's going to get moved to the bottom. So I need 49 to the 1/2 on the bottom, b to the 4th on the bottom. These guys up here have negative powers, they go down. These ones in the denominator have negative powers, they go up. 64 to the 1/2. And then c to the 3rd. I reiterate that this was not by any stretch the only way you could have done this. This was just one way. I mean, that's the thing about these problems, is that you can kind of go off and try different methods. As long as you're following the rules, you'll get the answer eventually. Right? You just got to keep going. And there it is, because 64 to the 1/2 is the square root of 64, which is 8, and 49 to the 1/2 is the square root of 49, which is 7. And again, you could find those with a calculator. 49 to the 1/2, etc. Don't forget to use parentheses around that half, though, if you're using old school calculators. All right. There we go. Sorry, I just poofed back, but what a mess this problem is. But the thing about it is that it looks so messy when you look at it like this. So don't get overwhelmed when you look at these problems and go, oh my gosh, it's such a mess. Okay, so we took what was inside the parentheses. We simplified it down, and that's what the first steps are. Matter of fact, I'm going to put all of that up on one line. Okay, and then once we had the parentheses broken down, then we distributed, see? So we distributed that power of -1/2 to all sorts of things. And then we had to break each one of those down and go, oh, that's 8 times 1/2, which is 4. That's 6 times 1/2, which is 3. And to be honest with you, most of the time, I don't show all these steps. I just kind of multiply it and make it -3. Then we flipped all the negative exponents around and finished it off. So it looks brutal, but it isn't. The first line of work was all simplifying the big inside that big parentheses. The next line of work was tackling that half getting distributed to everything. And then the last bit was getting rid of the negative exponents and finishing off what was left with the numbers. Okay, now let's do this one. Now we don't have a big parentheses on this one, so we won't be able to use the same techniques. That's the kicker about these problems, is that no one problem ever looks like any other problem. I mean, they all just seem so different, and that's because you can't try to learn these problems by learning a technique. It's not like that. It's more like you learn kind of the basic rules of exponents, which I showed you, and the definition, right, on page, it's what I talked about right here. So these properties, and then the definition on page 73. So these properties and what I was doing back here. You've got to know those. And if you know those, you can do any one of these problems, because you just keep fiddling around and keep fiddling around and keep fiddling around until you find the right answer. Okay, so let's look here. I don't have a big parentheses, so I'm not going to simplify inside the parentheses. What I can do is I can kind of distribute. I can say, okay, I want to take 81 b to the 8th. Oh, we already did this problem. Hold on. Poof. Okay, this is a total typo. I don't know why, but I had the same problem here. It actually had a typo in it anyway, so it's just a mess. So sorry about that. Let's fix these typos. So this was the same problem as that last one we did. Okay, so this is the one that should not be the last problem in the section, although it's actually quite tricky, so possibly it should have been. And we're going to totally change that problem from what it was to this, which I know is completely different. I have no idea what went on there, so I'm sorry. Okay, so let me write this out. There we go. All right, now here's what we're, oh, rats, I didn't write it correctly. There it is, now it's correct. Okay, so again, we don't have that big parentheses, similar to the one that we just got rid of that wasn't like this problem. So again, change this problem to this problem. It was a typo. Make it this. So we're going to distribute 8 to the 1/3. Then we have b to the 6, or -6, excuse me, to the 1/3. Then you have c to the 3rd to the 1/3. Okay, then on the denominator you're going to have 16 to the 1/4, then b to the 4 to the 1/4, and then c to the negative 12 to the 1/4. Okay, now the numbers use the definition that we learned before. So you go, okay, that's 2 over 2. 16 to the 1/4, 8 to the 1/3. If you don't believe me, use your calculator. 16 to the 1/4. And again, remember, parentheses for those exponents if you have old school calculators. All right, then it's b to the negative 6 times 1/3. C to the 3 times 1/3. Then down here it's 2b to the 4 times 1/4. Oops. There, that's better. And then that's what comes when you're typing and not looking. All right, c to the negative 12 to the 1/4. Oops, not to the, times the, oh my gosh, times 1/4. Okay, well, it looks pretty awful, but remember, 2 over 2 divides away, right? So you don't have any more numbers in this problem, other than the exponents, right? But no more coefficients. Now, b to the negative 6 times 1/3, remember that's b to the negative 2, because 6 over 3 makes 2. Remember, this is really 6 over 1. Nobody writes it like that, but that's what it is. And while we're on the subject, this is 3 over 1, so that's just going to be c. If you like it, c to the 1, because 3 over 3 reduces. This and this reduce down to 1. Same thing with this. 4 over 4 makes 1, right? Because this is really 4 over 1, and that gives you 4 in the numerator, 4 in the denominator. They're both gone. It makes it 1. So it's b to the 1. And then c to the negative 3. Oops, you probably want to see that. This is 12 over 1. 4 goes into 12 3 times. There it is. I put a little canceling in there. And then here, let me do this one as well. That way you guys can see it. So 3 went into 6 and left you 2 left over. That's why you had a 2. So over here it's going to be c to the negative 3. Now, you want b to the, now remember what you can do. You can subtract. Negative 2, take away 1. C to the 1, take away negative 3. I'm just using that property back here that says, right here, number 2. If I have, there we go. If I have b to the negative 2, that's my p, over b to the 1, that's my q, I can do b to the negative 2, take away 1. Same thing with c. C to the net 1 minus minus 3. There's always a subtraction in there, and then you put in whatever numbers you've got. So this is equal to b to the negative 3, c to the 4. Now you're not allowed to leave negative exponents in your final result, because that's not simplified. So you put c to the 4, b to the negative 3. Oh gosh, not negative 3, that was a mistake. B to the 3. Because when you move it down, you get rid of that negative exponent, because that's the definition of what a negative exponent is. All right, so it looks complicated, but let's see. We distributed the thirds and the fourths and all of that. Then we kind of simplified it down. That got us here. Now they're all simplified. Then we just used the subtraction property. And then we realized, oops, that got us here, and then we're not allowed, you know what, here, I like this better. So then we simplified, that's the simplification part. Then we used the subtraction property, that got us here, and then we had to finish it out. So this is the distribution, right here, distribution of the fractions, right? Then down here, this is simplifying the powers and the numbers, because the 2 thing, they disappeared. Then over here, we're using property number 2. And then we use the definition to finish it out.